So I showed this once before. It's a pre-assembled Zumo robot from Pololu. And at the time, I didn't really have any software, but it's intended to run the line maze and the table challenge, so I'll see how it fares here. It's completely untested here.
Ah, nice.
Awesome.
Is that from a kid?
Almost. It's supposed to go back to the middle of the table.
One more time.
Yeah, let's try that again.
It did one.
If it still runs, that's good for phase 4.
Yeah, it's fairly sturdy.
That'll all be edited out.
Oh.
Now it's kind of slow here. Oh, I know why. Anyway, that's another
Meant to do that, huh?
software issue.
Ralph, there's a question to say, where did this robot come from? Is this
It came from Pololu.
It'll fall slowly.
What's the sign?
Hey, there we go.
Let me get a picture of you and your robot.
Okay.
Just hold it.
All right, so that, for those of you who've never seen it before, that's what a table bot is supposed to do, go back and forth
That was phase 1.
without running off the table. That would be phase
Stand
1.
in front of there if you want. Oh, that's much better.
So is that from a kit?
That is from a kit,
Yes.
yes.
There you go.
All right, thanks, Ralph. Who?
So this particular one is not a kit. It's pre-assembled. It comes just like it is here, except I took the metal shield off because they also intended for Micro's sumo wrestling. And for the line maze, the shield gets caught on the cracks between the tiles, so it's better without it.
Cool.
But they do have a kit form of this as well.
Great, thanks. Okay, who else has a robot? We'll start on this side and move over here. Yeah? Mark?
So this is a work in progress. I'm not actually going to try and go anything, but if you remember was it the last challenge? I started off on the first in June and I had a robot and then I kind of dropped off the other two. So this is the continuation of it. It's pretty much all sensors at this point. It's got the line following sensors all on the bottom for the maze. I've got the sensors here on the edge so I can figure out when I'm going to go off. And then I've got some obstacle detection ones there. The big change for this one is that when I did it originally, I was using the Tiny Circuits Arduino. I don't know if anybody's familiar with that. I mean, it's a circuit board the size of a quarter, and then you kind of stack them up. But the problem with that is it didn't have enough connections for all these sensors by a long shot. So now I'm using the Teensy 3.5, if anybody's familiar with that. Teensy 3.5. I think it's got like 60 connectors connections you can have it in. It has like 3 or 4 different I2C buses and everything else. So I have this huge mass of wires here on top from all the sensors and power and everything, and I'm going to be spending the weekend actually hooking them all up and getting the hardware ready so I can actually write the software for June. So, but it's gonna rock. And it's all 3D printed parts on the bottom there. Yeah, Mark.
Are you going to, I mean, did you know that the Arduino 1.6.12 and so IDE supports Teensy as a, you pull in the modules with a compiler and everything, and you can develop in the Arduino IDE.
Yeah, so I don't know if you're talking about you're talking about the Teensy Duino that you're talking about?
Well, I know they do Teensy 3.2, but one of the processors that has support for Arduino IDE, it's convenient.
Yeah, no, we use the same processor on our Robo Magellan as well, and I was using the IDE, the Arduino IDE for that. And there's a Teensy Duino library that you install into it, and it brings in all the libraries and everything.
And there was a question on the list, so I don't know if that person is here, but
Yeah.
This is another example of what you can do with that IDE.
Yeah, they've really made it so that IDE is pretty
Great.
extensible. Yeah,
Nice.
and you know, a lot of the libraries will work on the Teensy kind of out of the box, but I have found that I've had to go in and modify them. Particularly if you're using like the I2C, they have a different I2C library because there's so many different buses. You need to actually specify the pins that you're using and everything. What else? There was also they have their own interrupt stuff and everything. But if you're okay with going in and mucking with the existing libraries and code and just swapping stuff in, it's almost a one-for-one replacement. And so, yeah.
Nice. Thanks.
Well, this is another work in progress for the upcoming Table Bot Challenge. So this is a collection of parts basically from Pololu cobbled together. And although I don't have it set up to do the down and back routine, we'll just see how it works here.
Yeah.
Okay.
Wow. It'll go around and kind of find all the edges and maybe decided to take a dive here, but we'll see. I've already had problems with different color tabletops and
Call that a success.
and sometimes if you get a shallow enough angle going onto the edge, it's tough. But anyway, you know, when it turns around here in a minute.
Those aren't real eyes.
Yeah, the vision system is going to need an upgrade here for phase 2 and phase 3.
That's great.
Thanks.
Yeah. So where did you design the base for that, or is that from a kit?
The base, the motors, and wheels are from a project that we did up at Robot Garden in Livermore. So it's that design was a collaboration of several people. The controller here is an Arduino compatible Pololu board. It's got a 32U4 chip, and it's got the some motor driver chips built in, so that don't need a separate motor driver to drive the motors.
Nice.
All right.
So I've driven around and made the map, made a map. Something that we're doing at the HBRC SIG, our special interest group, is ROS, and we're applying ROS on a Nito bot deck. Incidentally, I work at Nito Robotics, so this is full disclaimer here. And we have our HR director and our director of global communications back there, so you guys better be on the best behavior. That's Amanda Shepard and Aparna Aswani. Amanda, did you want to say something?
We're always looking for good talent.
We're always looking for good talent, robot building talent, that is. So go to our careers page and check it out. And if you're worthy, send in your resume and get on board. Anyways, so this is the Nito bot deck, and we're hacking it. We're putting the Raspberry Pi in here, and Dr. Alan Fetterman here and the SV Ross group, Ralph Ganock, thank you, has put the bot deck package on a micro SD card that plugs into the Raspberry Pi 2. So for like 40 bucks, you can plug it in, and if you know Linux, you can get this thing running and going pretty fast. And what I've done here is, again, I've created the map, and I've saved the map. Save the map before you kill the mapping program, and then you load in the navigation routine. And he may have gotten a little delocalized there, so bear with me. I'm going to click. Where am I going to click? It's not too far. If you think I should just go with it, I'll go with it. So Fetterman says go with it. Here's my 2D nav goal. I'm going click, and I'm going to run to the opposite side here of the stage, exit stage right. And so here comes the robot navigating, autonomous, no hands. So here you see in RViz, the ROS visualization tool, the model of the NitoBot DAC as it's traveling. And you see the green line there, that is your path planning line. And the red line that I set over there is the goal. And so you see him navigating to the goal. And in less than a minute, he will arrive at that goal, and he will arrive at that goal. What do you have to say?
Effects, so it has to have messages like, I can't do that, can't.
Comedy musings down the Federal, ladies and gentlemen. Okay, so there you see him navigating. Actually, I'm going to try something dangerous here. I shall stand in front of the robot. And let's see what happens. Whoops. So you see him path planning around me. You see that? So this is what Chris Mayer was talking about with building more sophisticated robots. All of us, some of us, for years have built the bump and go, the obstacle avoidance robots. You may have built a dozen of them. But this is another level of intelligence. This is actually navigating. That is knowing where you are in the environment, and that takes the robot to another whole level. So if you're interested in ROS, if you're interested in navigating, doing things with robots, it's all about navigating and delivery after all, isn't it? The HBR SIG's a great place to come. BotDAC's a great trainer. There he goes. He's okay. Well, no, that doesn't fit too well, but he's kind of sort of got there. You get the idea. So before we close here, I'm going to make an end run. Let's go all the way to the other side.
Miami.
Yeah. 2D nav.
Niagara.
So I'm all the way. I'm going to go.
That's Miami.
Marvin in the left corner pocket there, all the way on the other side. So. Here's my pointer. There I am. Oh, I've already got the nav goal tool, and I'll place it down here. Point, press, drag. We'll have him face the opposite way when he gets. Oh, now he's going to. That's dangerous, isn't it? Yeah. Didn't expect that. The robot's going to go into unknown territory.
It's going to go into cheers.
All right. Well, this is bad. This is bad.
And now's when you say thank you very much.
This is bad. I'm going to try to rescue him, but I'm going to do that off stage. Thank you very much.
I think he's going to make it.
I got more confidence in that robot tonight.
Avoided this stuff just a second ago.
Yeah, but now it's really in the unknown territory. I'm going to help him out, though. I'm going to guide him with a little teleop twist. I'll shut up.
So those of us who have been working with robots for a while tend to use a lot of acronyms. Camp used ROS, which didn't hear him defined, but there's a lot of new people here. So the ROS is the Robot Operating System, and it's the only open source set of libraries and procedures that has survived. There have been others. I know NASA has an open source system for navigation and mapping. There was a closed source system that Microsoft came out with. But ROS is really the one that everybody uses, not just for homebrew projects, but also for commercial projects as well. So if you're interested in more advanced robotic techniques, including mapping, path planning, visualization, ROS is the way to go. And that's what the special interest group discusses the week before this general meeting. That's what Alan was talking about. The SV Silicon Valley ROS meeting is a way you can get more information.
So I navigated him over back to where the known space is. So now he'll traverse down the hallway and make it to the goal.
Hi, my name is Sarah, and I'm with Intel. I work for Perceptual Computing Group. known for real sense and depth camera technologies. Today I'm going to talk about Intel Euclid, which is just out in the market. It's been 2 weeks since we launched, and we also showcased a lot at Maker Fair if you were there. I'm going to talk about what this is. What I'm holding in my hand essentially is a full computer running Ubuntu 16.04 and robot operating system. And what I have here is the web interface, which I'm going to show some demos on. So this is basically a quad-core. This has quad-core CPU, Bluetooth, Wi-Fi. It has a depth camera, a stereo-based depth camera. It also has a fisheye camera, an IMU. It has GPS built in. It has a magnetometer and a bunch of other sensors. So essentially everything with the battery all in this tight little package. Because it has Wi-Fi and runs Ubuntu and ROS kinetic command built in, we have created a software stack on top which enables you to access the device from pretty much any device over Wi-Fi just using a browser without installing any piece of software. What I'm going to show is I'm going to run the camera scenario. What a scenario is basically an application running on a robot. It's basically a combination of a bunch of ROS nodes. So for example, I'm running the camera scenario and it has 2 different ROS nodes running, or Euclid nodes. Think of Euclid nodes as launch file with some configuration parameters. So we'll see what this looks like. So I have color, fisheye, and depth. And I have it streaming right over here. So I have like the color stream, depth, and fisheye. So what we are trying to do is make it super easy to develop your own applications on robots using ROS, and giving it a nice web interface you can use from your smartphone or even your laptop, anything, right? Even if you're running any operating system or any phone, it doesn't matter. You only need Wi-Fi and a browser. Okay, so what I'm quickly going to show is how you can program a robot. So out of the box, we also have like TurtleBot software installed. So you have TurtleBot stack running on it. We also have some serial capabilities, so you can communicate with Arduino-based device. So what I'm going to do now is going to put this guy on the TurtleBot and try to get it to follow me. See how that goes.
Hey, all right.
All right. Yeah. Yeah. So what I'm going to do here is I'm going to start a scenario. Let's point it to myself. See it. So it's basically tracking me and following me, and so it tracks me here, you can see.
I think so. Hey Tony, it works.
So this thing can do this out of the box because we already ship with.
You need to demo that a little more, walk around here.
Okay.
We're heavy on the demo.
All right.
There you go. All right.
All right. Let me.
That's fine.
How does it know that you're the person to follow?
So it can track up to 5 to 6 people. It will track the first one, it seems, and it basically focuses. So this is like a quick little demo we made with it. It's basically running a ROS packages.
Okay.
So that's what I'm going to talk about real quick. That what it does inside. So I'm running the TurtleBot person follower scenario here, and it has a bunch of ROS nodes running. So one is for cameras, it fetches the camera data. The second one is depth transcode, so you can see the depth data. Not bumping. It likes me. Then we have some other things like person tracking. So we have a person tracking algorithm running on it. And then person follower, which is what it's doing right now. And then we have something called robot movement controller here, which is basically sending command velocity messages to the robot base. And then it says that it's TurtleBot. So basically, we are running the TurtleBot stack. So basically, we are running the TurtleBot bring up minimal launch file. Now, we are also giving modular development with this. So you can create one of these scenarios right on this interface right here. And you can create any kind of scenarios you want. So for example, I want to use the same algorithms for a person follower, but instead of a TurtleBot, because I don't have one, I made my own Arduino based robot. What can I do? So what I'll do is I'll just select the first 4, and instead of a TurtleBot, I'll just pick the Arduino based node, which is basically communicating to any Arduino board over serial using the USB provided on the device, and then it will communicate over serial and control the Arduino robot, which runs a ROS library. And you can pretty much use any ROS enabled robot that way right out of the box. It will, as long as it receives command velocity messages. Yes.
Where's the master running? Where's the ROS master?
So the ROS master is running on that device itself. So it's essentially, it's a full computer. You can plug in a monitor and a keyboard, and you'll see your familiar Ubuntu desktop environment where you can program your own ROS packages and do stuff like that.
So you're using a computer on the Euclid, right?
Yes, there is
To
no
control
other.
the TurtleBot?
There is no other computer on the TurtleBot right now.
Okay.
So basically, what we did is we took the laptop and the depth sensor on the TurtleBot out, and we basically combined them into one with a battery, and that's basically Euclid for you. It's a very tight form factor. We are on sale right now. It's going for $399, which is slightly expensive, but if you think about it, yeah, it's $400. But if you think about it, it's basically a laptop and a depth camera combined, and running ROS out of the box, so you can use it for making your own robots.
And it's going directly into the USB port of the
Yeah, so yes, so there is a USB port right here.
USB 2?
Yeah,
On
the TurtleBot it's USB 2. It comes with a USB 3 port. It has a micro HDMI and a charging port here.
Now, a regular RealSense is only USB 3 out, right?
Yes. Yeah, and this you don't have to really plug it into any other computer. You can do so if you have a more powerful ROS-enabled machine. You can connect it over IP and just connect it through ROS. Configure this as a master or a host, so you can have 2 machines communicating with each other. So you can send data from the imagers to other powerful machines. Say, for example, with an NVIDIA GPU to do some machine learning. Any other questions? This is all open source, by the way, the whole software stack here. So you can go modify, add your own stuff, add your own packages to the UI. We have an interesting set of tutorials on the Euclid community page. So we are trying to build an open source community around the product itself. It's called, you can find it at euclidcommunity.intel.com. And I'll share later if anybody is interested. There you can find different tutorial videos, like 13 2-minute videos to get you up and running with the device itself.
Do you have a line scan?
I don't have a LiDAR on this. You can plug a LiDAR over USB.
And can you use that to do a simulated?
Yes, so it runs the AMCL G mapping demo. And you can do like a laser scan, so depth to laser scan conversion, and then you can do the same thing, like autonomously navigate this robot, for example.
How does it do that?
So it has a stereo IR camera, so it does stereo matching. Can do depth indoors and outdoors up to 8 feet.
What's the capacity of the battery built in?
So the battery is a 2200 milliamp hour battery. It will last for up to 1.5 to 2 hours with the cameras running, and can go up to
1500 watts.
Don't know the exact number. I'll double check. But it will last up to 2 hours with the cameras running, and it will last up to 5 to 6 hours without the cameras working. Yeah, input output. So we have one USB 3 port here. We have a micro SD card slot, so you can expand up to 128 gigs. It has 4 gigabytes of RAM on device, and it also has 4 GB. So 4 GB RAM, 32 GB memory, and we have an OTG port, which also doubles up as the charging port, which is a USB micro B port, and we have 2 programmable buttons, which you can program to either start an application.
Can I do everything what Microsoft Kinect did, like skeleton?
It doesn't do skeletal tracking out of the box, no. So we do have like person tracking, so it will track up to 6 people. So we have like RealSense middleware to do person tracking. It also runs RealSense Slam middleware, so it does 6-DOF tracking as well. So it uses the fisheye and the IMU to do positional tracking in a room.
Your question answered. Okay.
Does it have Ethernet?
It doesn't, but you can use your USB to Ethernet dongle and connect to your Ethernet port.
That way the little USB ports will pull out as the robot drives around from the vibration. What's the field of view?
The field of view?
And the min and max depth?
The minimum depth you can do is 30 centimeters, and the maximum is 8 feet.
Field of view, sorry?
The field of view is 45 degrees, horizontal.
CPU, GPU?
So it has the Intel Atom processor, so it has a quad-core CPU, and I'm not so sure about the GPU, but it's on the specs on the website itself, so you can find all that information over there. Cool.
Thanks very much.
Just a real quick announcement. Some people asked me about joining into these meetings remotely, so I did set up a Google Hangout to do that. Unfortunately, we are not allowed to connect directly to Google's internal GVC, which is what we see here. So if anybody does want to join remotely, what we'll do is I'll just set up my laptop, point it out at the audience, and then we can join in. And because some people wanted to present robots and do the challenges, but they didn't want to have to mail their robots in. So this way they can do it remotely. And anybody else, if you're traveling and you want to join in the fun, there's a thread on that also in the news group.